Good morning to all of you. My name is Vishal Jaiswal and I am Assistant Professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Here we are going to discuss the topic 2's complement, addition and subtraction, that is given in computer organization and architecture subjects. And if we talk about 2's complement, addition and subtraction, the leftmost bit of binary number represents the sign bit, and that means 0 for positive and 1 for negative. If the sign bit is 1, the entire number is represented in 2's complement form. If we talk about 2's complement, we take 2's complement of the negative number only. We don't take the 2's complement of positive number. First, this is the important thing about the 2's complement. Let's suppose we take the number. Let's take the number that is minus 6. If we take the minus 6, if we represent in minus 6 in 2's complement form, first we take the binary of minus 6. That is first we write plus 6. That means plus 6 means 0, 1, 1, 0. This is the representation of plus 6. And if you want to represent minus 6 in 2's complement form, 2's complement form, then we take the plus 6. We write the plus 6 in binary number, that is 0, 1, 1, 0. It means 1, 2, 4 and 8. 4 plus 2, that is 6. Then we take the 1's complement of this number, that is 1 after 1's complement. 1's complement. It means the bit is inverted from 0 to 1 and 1 to 0. Means that this 0 becomes 1, this 1 becomes 0, then this 1 becomes 0 and this 0 becomes 1. Then we add the plus 1 in this number. So 1 plus 1 is equal to 0, 1 carry, 1 plus 1, 1 plus 0, 1, 0 and 1. This is the 2's complement representation of minus 6 in this form. This is on 4-bit. Basically, this is a 4-bit representation of minus 6. Here, if we talk about the binary number, if we say the binary number minus 6, if we represent the minus 6 in binary number, then for sign bit we use 1 and the magnitude part, that is 6, that is 1, 1 and 0. This is the representation of binary number of minus 6, and this is the representation of 2's complement form of minus 6. If our number is positive, let's suppose we have plus 6, then we write 0, 1, 1, 0. Here 1 bit, 1 for negative number and 0 for positive number. Two's complement, if we talk about the 2's complement, the addition of two numbers in signed 2's complement form consists of adding the numbers with sign bits created the same as the other bits of the number. A carry out of the sign bit position is discarded. The subtraction consists of first taking the 2's complement of the subtrahend and then adding it to the minute. When two numbers of n digits are added and then sum occupies n plus 1 bit digits, we say that an overflow occurred. An overflow can detect by inspecting the last two carries out of the addition. When the two carries are applied to an exclusive OR gate, then the overflow is detected. When the output of the gate is equal to 1. Basically, when we add the two number or subtract the two numbers, then the possibility of overflow in the addition or subtraction. Basically, overflow occurred when the numbers of the same sign, either positive positive or negative negative, if we add the numbers with the same sign or subtract the number with the same sign, then the possibility of overflow will occur. And one another thing is that if we add the n digits number and the sum occupies the n plus 1 digit, then we can say this is the overflow. This is the formula for overflow that we can check, that is C in XOR C out. C in XOR C out, that is equal to 1, then overflow occurred. We can discuss this thing in the example. The two sign bits are added and or subtracted together with the other bits in the complementary and parallel adder. The overflow flip-flop V is set to 1 if there is an overflow. The output carry in this case is discarded. Basically, if we add or subtract the numbers, if we got the carry output, then we discard that carry. We cannot store those carry. And for overflow detection, we have a 1 bit flip flop, that is a V, that is set to 1. This is the hardware implementation of 2's complement addition and subtraction. Here we are the two register, that is a B register and AC register, that is accumulator register, and here is the complement and parallel adder where the subtraction and the addition is performed. And if we face the overflow, then V is set to 1. Basically, overflow mentioned here. If V is set to 1, then we can say that there is an overflow, otherwise there is no overflow. This is the algorithm for addition and subtraction. For addition, if we talk about the addition, there are the two terms, augment and addend. Augment in EC accumulator register and the addend in B register. And if we talk about the addition, that means AC tends to AC plus B. Basically, in addition, we perform the addition on the two numbers AC plus B. First augment in AC and addend in B. If we occur the overflow, if there is an overflow, that is mentioned in B, that is a flip-flop, and this is the AND. And if we talk about the subtraction, and in subtraction, minuend in AC and subtrahend in B. And in subtraction, we first AC plus B bar plus 1. Basically, if we talk about the subtraction, there is in computer, there is no operation like subtraction. We perform subtraction by the 2's complement form, and 2's complement form, that is B bar plus 1. Then if there is an overflow, we detect an overflow. If V is set to 1, then we can say that there is an overflow, otherwise not. Then AND. The sum is obtained by adding the content of AC and BR, including their sign bits. The overflow bit V is set to 1 if the exclusive OR of the last two carries is 1 and it is cleared to 0, otherwise the subtraction operation is accomplished by adding the content of AC to the 2's complement of BR. Taking the 2's complement of BR has the effect of changing a positive number to negative and vice versa. and overflow must be checked during this operation because the two numbers are added could have the same sign. This is the range for 2's complement number, that is minus 2 की power n minus 1 through 2 की power n minus 1 minus 1. If we talk about here, the value of n is 4. If we take the value of n is 4, then we can say that minus 2 की power 4 minus 1, that is minus 2 की power 3. It means minus 8 through that is 2 की power n minus 1 minus 1 means 2 की power 4 minus 1 minus 1 means 2 की power 3 minus 1 means equal to, this is plus का 7. Means if we take the 4-bit number, that is n equal to 4, then the range is minus 8 to plus 7. This is the range for 4-bit number in 2's complement form. Let's take in some examples by which we can discuss addition and subtraction. First is minus 7 and plus 5. If we want to perform minus 7 plus 5, then we first write minus 7 in the form of plus 7 in 4-bit, because these two numbers, that is 7 and 5, have 3-bit number and 1 for the sign bit. Then plus 7 is represented in 4-bit, means 0, 7 for 1, 1, 1. This is the plus 7. And if we take, if we want to add these numbers, we have to take the 2's complement form of minus 7, 2's complement form. First we take the 2's complement form of minus 7, then we add to the plus 5. For this, first we write the plus 7, that is 0, 1, 1, 1. Then we take the 2's complement of this binary number. If you want to take the 2's complement form of this binary number, there is a method. First we take the 1's complement, then we add plus 1, add 1, then we got the 2's complement form. Another method is a direct method by which we can take the 2's complement of any number. Let's suppose we want to take the 2's complement of this number, then we have to write down this number in 4 digits. Then we see the number from the right. And we see, that is when the first ones occur. Let's suppose 0 occurs, then 0 becomes 0, no change in any number. Let's suppose first 1 occur here, then we have to write 1, and the remaining numbers inverted form, and we inverted the remaining numbers, means 1 becomes 0, 1 becomes 0, and 0 becomes 1. This is the 2's complement form of minus 7. This is the direct method. We can see from the right and we search for the 1. Let's suppose 1 is given in the first position, then we have to write as it is 1. Then after, all the numbers becomes inverted, means 1 to 0, 1 to 0, and 0 to 1. This is the 2's complement form. So our first number is minus 7, that is 1001. Next number is plus 5. What is plus 5? Plus 5 means 0, 1, 0, 1. This is plus 5. We have to add, let's suppose plus sign. We have to add this number 1 plus 1, 0, 1 carry, 1 plus 0, 1, 1 plus 0, 1, and 0 plus 1, 1, 1 plus 1, 0. This is the result of minus 7 plus 5. And this result is in 2's complement form. Basically, this result is given in 2's complement form. Complement form. If we add minus 7 plus 5, we know that we got the number plus 2. Minus 2, sorry, minus 2. So, if we add minus 7 and plus 5, we got the result, that is minus 2. And this is minus 2 in the form of 2's complement. So, if we want to see the result that this is the minus 2, then for the for this number 1, 1, 1, 0, for the sign we have negative, this is 1, so we take the sign bit and write all the whole number, that is 1, 1, 1 and 0, and take the 2's complement of this number. Then minus 2's complement of this number, see from the right position, right side, and when the first one is occur, write down as it is, and the remaining number that are being inverted. So 0 becomes 0, there is no change. First one occurred here, so this is write down as it is. Then after this, these two numbers are inverted, means this one becomes 0, this one becomes 0. This becomes, that is minus 2. This is the answer. If we add minus 7 and plus 5, we got the result minus 2 in the, and this result is given in 2's complement form. We can practice another question that is given in minus 4 and plus 4. Next question we take, that is minus 4 and minus 1. Let's suppose minus 4 and minus 1. If you want to this minus 4 and plus minus 1, then we take the 2's complement of this number and we have to take the 2's complement of this number, because both are the number are the negative number. So we take the 2's complement of the both number. For the plus 4, we write down the plus 4 in 4 bit. That means 0, 1, 0, 0. This is the 4-bit representation of plus 4, and we have to take the 2's complement, means 0, 0, 1 and 1. This is the minus 4, and for minus 1, we have to write plus 1 in 4 digit. That means 0, 0, 0 and 1, and if we take the 2's complement form, then 1, 1, 1, 1. This is the 2's complement form of minus 1. So we have to add these two binary number. So we write down minus 4 and minus 1, minus 4 is 1 1 0 0 and minus 1 is 1 1 1 1. We have to add this number because there is a sign of addition. 0 plus 1 becomes 1, 0 plus 1 becomes 1 and 1 plus 1 becomes 0 and 1 carry and 1 plus 1 becomes 1 plus 1 becomes 0, 1 carry and 1 plus 1 becomes 0, 1 carry and 0 plus 1 becomes 1. Here this is the C in and this is the C out. Basically we can say that this is C out and this is C in. And this is the result of minus 4 and minus 1. And if we want to add minus 4 and minus 1, then result should be minus 5. We can say that this is minus 5 or not, because there is the first position bit is 1, then we can say that this result is in 2's complement form. This result is in 2's complement form. If we want to see the result, actual result, then we have to take the 2's complement of this number. So for this minus, we have to write minus here and write down the whole number, that means 1 0 1 1 and take the 2's complement. That means this becomes minus 0, sorry, this becomes 1, this becomes 0, this becomes 1 and this becomes 0 and this is minus, this resultant is minus 5. So we can say that we can add minus 4 and minus 1 and got the result minus 5. And we can also check the overflow condition, because here we have the two carries C in and C out. If we want if we want to check the overflow condition, then we have the formula. This is C in XOR C out, that is equal to 1. If C in is 1 and C out is 1, if we take the XOR of the same number, we got the result 0. And if we take the XOR of the different number, means one is 0 and another is 1, then we got the result 1. So we can say that we take the C in C out XOR and got the result 0. It means there is no overflow in this question. We take the another question, that is a minus 4 plus 5, and we got the result plus 9. If we add plus 4 and plus 5, then we have to got the result plus 9. So we can plus 5 plus 4. By looking at once, that means plus 4 plus 5 plus 4, both numbers, both magnitude part, plus 5 is a 3-bit and 4 is a 3-bit number, and plus for 1 bit means there is a 4-bit. We perform the addition in 4-bit. If we take the result, that is plus 9. Here 9 is a 4-bit number. 9 is a 4-bit number, and there is another bit for plus. That means result of 5-bit. So here the condition of n bit, if we want to add n bit numbers and the result that is we obtain, that is of n plus 1 bit, then we can say that there is an overflow. This is the case of overflow because we add plus 4, plus 5 and plus 4 in 4 bit and we got the result plus 9, that is of 5 bit. Then we can say that this is the overflow. So we can check this question from the our C in C out method. So let's perform this question. Plus 5 and plus 4. Plus 5 means we have to write 0 1 0 1, that is plus 5. Plus 4 means 0 1 0 0, this is plus 4. We want to add this number. 1 plus 0 1, 0 plus 0 1, 1 plus 1 0, 1 carry, 1 plus 0 1. Here there is no carry and here there is a 1 carry. So C out, value of C out is equal to 0. If there is no number, we can assume the value is 0. And C in value is 1. And if we want to XOR this, then we got the result 1, means there is an overflow. This is the first condition by which we can check the overflow condition. And if we want to check by another method, then we can say that if we perform the addition or subtraction on the same sign, means there is a sign bit 0, there is sign bit 0, and got the result is that is a minus 1, that is a different sign, then we can say that there is an overflow. Here there is an overflow. So there is no result possible in 4 bit. Thank you.